17/6/2022.
Mhm.
So will it be extended for week 6 or will it be on that date only?
Just a minute, bro. As far as I know, we're planning to extend for week 6. Just a minute, let me check. Just a minute. Give me a minute. I'll let you know.
Sure, sir.
Hello. So yeah, so I guess there will be no extension for week 6 graded deadline.
So both will be on the same date.
Yes, yes.
Okay, sir.
Okay.
Today, will you be explaining or taking the questions of practice assignment and activity question because I haven't completed anything?
No, I'm planning to take some question and see if you have some kind of conceptual doubt, then probably I can also explain at the same time. I can explain few of the concept. If you have some doubt, then I can go to the questions. So
Okay, sir.
so it's depend like what kind of question I'm getting from you, like.
Okay, I got it. So you will take the question and explain it on the way.
Yeah, if you have some conceptual doubt regarding that question or you don't know the theory behind that, then I can explain the theory and I can go to the question after.
Okay, sir. I got it.
Sir, can we ask the question from activity 6 week 6?
Yes, yes. So this session is basically for week 6. So you can ask question from week 6.
Yes, sir. Sir, activity 6.1 question number 5.
Okay. Question number 5, right? So
Yes, sir.
yeah, so basically this question is asking about the domain of a function, right? So so what you need to do, you need to find. So the question, so this is basically activity 6.1, question number 5. Yeah, so basically what you need to do, you need to find uh, domain of the functions. So my function is log of minus x minus 3x x into e power 3x minus 27x, right? This is the question.
Yes, sir.
So, okay, so we need to find the domain of this function, right? So basically, as you can see, this is certainly this is a single function, but we can write it as composition of two functions, right?
Yes, sir.
So this is basically log x composed with this x times 3x minus 27. So so what I want to find the domain of the function, and I know that log of x, this function, so log of x is defined.
Sir, how we write this log x multiplied with this?
This is not multiplied. Okay, so my bad. So this is basically composition. Okay, this is not multi, right? This is composition of two functions. So if I compose this function with this function, then I will get this function, right?
Yes, sir.
So yeah, so if suppose this is my let's say h, and this is my g, right? I have two functions. So h is basically log of x, and g is whatever this expression. So if h of x is this and g of x of this, and if I compose h with g, that is h circle g, then I'll get, so this is nothing but f of x. Okay, so this is composition. Okay, so we know this log of x is defined only when
0 to infinity.
Yeah, correct. Only when x is 0. All right, x is strictly greater than 0. So now instead of x, I have something else, right? I have something else.
Yes, sir.
So I want this term to be greater than 0, right? Then only I can say that if this term is greater than 0, so instead of x, I have something else. I have some you say some g is there. Okay, instead of x, I have some different function is there. So here basically this I'm composing. So here basically g is x. So here g is something else. I have some different function. So I have to find all the values of x for which this g of x is greater than 0. Okay, so I can say that. F of x is defined if and only if this thing is greater than 0. This x times
e to the power 3x minus 27x.
If this thing is greater than 0, then I can say that my function f of x is well defined. Okay, so I need to find the range for which this function is greater than 0. So this is greater than this is greater than 0. So I have a minus term. So I have a minus term with this function, right? So if I multiply minus, then whatever this equality, it will get reversed.
Change.
Yes, correct. So this is same as x into 3x, x into e power 3x minus 27x, which is less than 0, right?
Yes.
And this is same as I have x here, and I have also x here. I can take x out of that expression. So this is x times e power 3x minus 27, which is less than 0, right? So finally I'm left with this one.
Yes, sir.
So I want these two things to be less than 0, right? So suppose you have two number m and n. These are two number, and suppose m times n is less than 0. So what are the possible sign of m and n? When product of two things can be negative.
Sir, m is negative and n is positive.
So you have two options, right? Whatever,
Yes, sir, two
yes,
cases.
Correct. Whatever he's saying, it's correct. So this is possible. So the
Yes, sir.
first case is, so the
M
first,
positive, M positive, M negative,
so the first case is M is positive
N negative.
and
N is
And-
negative.
N is negative. Okay, let me,
Yes, sir.
M is positive and N is
Negative.
negative. And the second case is
M negative, N positive.
correct.
Negative and positive.
M negative and N is positive.
Positive.
And so similarly, we have two things here. So this is one thing, and another thing is e power 3x minus 27, which is less than 0. So from here, I can conclude two things, right? So I can conclude two things. So the first thing is, so the first case is x is greater than 0. Sorry, x is less than 0, and e power, okay, let me follow the same rule. X is greater than 0 and e power 3x minus 27 is less than 0. Okay, so from this case, I will get a range for x.
Yes, sir.
If I solve, okay, I'll solve it, but using these two things, I can get a range for x, right? I can get a range for x. And similarly, I have a second case. Which is x is
Negative.
negative and e power 3x minus 27 is
Positive.
Or positive.
positive. So again, from this thing, if I solve both the inequality, then I will get a range for.
Sir, we can solve for both cases and take intersection of both.
Correct. So whatever intersection we have, so finally you will get a range for this thing, first case, and the second will get a range for the second case. And in the end, you will get not intersection. You have to, yes, correct. You have to take the intersection.
Union.
Yeah.
Yeah.
No.
Intersection.
You have to take the intersection. Okay. So you want this to be whole.
Yes, sir.
Yeah, so you want both to be whole, right? So okay, so let's try to solve both the things. So let me solve the first case. Okay, so till now it's clear, right?
Yes, sir.
Yes, sir.
Okay, so x is greater than 0, that is fine. So this means x is basically in between 0 to infinity, right? So this x greater than 0 means x is basically in this interval. So, and this means e to the power 3x is less than 27. Right? That means if I take the natural log, what I will get?
So 3x
3x
equal to 3 log 3.
ln of 27.
ln of 27, right? And now x is less than 1 by 3.
ln 27.
ln 27.
27.
And basically what you have this you have some rule for logarithm, right? See,
Yes, sir. It will ln 3.
a log b is nothing but log
B to the B
B to the power A.
right? So
Yes.
if I take the power, what I will get? It's basically ln 27 power 1 by 3, right? And which is nothing but ln
3q is equal to
3.
ln 3.
Correct?
Yes.
So here what I'm getting x equal to less than ln 3. So now I have x equal to less than ln 3. So that means x is basically in this interval, minus infinity to
ln
3. And so I have now two cases here, right? X is greater than 0. In the first case, I have two sub cases. X is greater than 0 and e to the 3x minus 27 is less than 0. So from the first case, I'm getting x is basically in this interval, right? and from the second thing, from this one I'm getting x is basically in between -infinity to ln3. So what is the common region?
0 to ln.
0 to
Correct.
ln3.
0 to
So the
ln3.
common
0 to ln3.
0 to ln3, sir.
is basically 0 to ln3.
Okay.
Okay, so this is what we are getting. So basically this is what we are getting, so this is the range we are getting for the first case, right?
Yes, sir. Case 1.
For the first case. And second case is not possible, you can check. Okay.
Yes, sir.
This case is not possible. It's pretty easy. Like, as you can see, this means x is basically in between -infinity to
0.
0, and this implies e power 3x minus 27
Yes.
is greater than 0, right?
Yes, sir.
That means e power 3x is greater than
0.
not
27.
27.
Yes.
And this is
Same as
nothing but
before.
x is greater than
ln3.
3, right? So from the first one you are getting
No,
that
sir.
x is basically in between -infinity to 0, and from the second one you are getting what? X is basically ln3 to -infinity, right? So basically you don't have any common region in between these two, this one and this one, right?
Yes, sir.
So this case is not possible. The second case is not possible. Is it clear?
Yes, sir.
So then you have only one region for one region in which this whatever this expression is less than 0, and that region is basically x in between 0 to ln. Is it clear?
Yes, sir.
Okay.
Yes, sir.
The question number 3 also this question.
Question number 3.
Yes, sir.
In the same.
Yes, sir.
Okay, so
Sir, after that, can you please explain little bit the domain of log thing?
no, this is okay. So the thing is, so you know the domain of log, right?
0 to infinity, that I
Yes.
know. But
Yeah.
in separate thing, they are taking the range. This is confusing sometimes for few.
No, once as I like just now I have explained you one example, right?
Yes, yes.
So similarly, so the main thing is, okay, so main thing is you have something. So instead of x, so most of the time instead of x you will have something else, right? Some different function. Okay, so basically you need to find the range in which that
function.
Yeah, you have to find a range in which that function is always positive. Okay, that is the main idea. Okay. So basically you'll have something log of, okay. So the main idea is, so most of the time you see, one thing is pretty obvious, that you know the log of this is the domain of this function log x is 0 to infinity. That is clear.
This is predefined, right, sir?
Yeah. This is not predefined. Okay, so the thing is the way you are defining this log x. So the thing is what you have this function, right? So you have. I will come to someone asked me this activity question number 3. I'll solve. Okay, let me explain this. I'll come to that question.
Okay, sir.
So you have this function, right? So the initial stage is what you have, this exponential function, some ax, right?
Yes.
And obviously a is so you have some condition on a.
A not equal to 0, a not equal to 1.
And also a is not equal to. Okay, let me write it properly. A is greater than 0.
A not equal to 1.
And no, a is not equal to 1. Okay, that is the
Yes.
condition. So when you have this function, so you have this function, so the domain of this function is what? Whole real line, right?
Total R.
Total R, right? So, so, and the range of this function,
0 to infinity.
0 to infinity.
this function is always positive, and so the range of f is 0 to infinity. Okay. So now when I'm defining this function, so suppose I'm considering this function. So my domain is R.
From this, the log is inverse of that. So that's why the range of this a to the power x is domain of log x.
Correct. So when I'm defining this, so this is a map from R to 0 comma infinity, right? And this is a bijective map. This is a bijection, right? This is 1, 1, and as well as this is on, right? So, okay, so basically, one thing is so it's pretty easy, more or less. It's easy to prove this is 1, 1, but it's not easy to prove this is on. Okay, so because you need some, I guess you need some kind of continuity.
Domain, condomain, and loss.
You need some kind of continuity. Probably you need some continuity argument to show that this is onto. Okay, so this is a bijection. Okay, so if you draw the graph, basically you can see. So the graph, let's say A is greater than 1. So if A is greater than 1, then this graph will look like something. Okay, if A is greater than
a to the power x.
Yes. So this is a bijection. Okay. So what I'm doing now, since this is a bijection, so I can take the inverse of this map. Okay. So I can not take, I can talk about the inverse of this map. So then since this map is a bijection, then this map.
Sir, one little question here.
Yeah.
Sir, as you showed that it is a continuous function, that's why it is bijective. So, sir, are all continuous functions?
No. I never said that since this is a continuous function, that's why it's bijective. I said to show that this map is onto. Okay.
Yeah.
Probably you need this continuity argument. Probably. Okay. Yeah. Certainly you okay, not probably, you can do it continuity using continuity argument, but I don't know whether you can use some other argument to show that this map is onto. Okay, but okay, I understand your question. You are asking the converse. No, all continuous map are not onto. Okay, or maybe you can say all continuous map are not bijection. Okay. So okay, so then this map has an inverse. Okay, if this map has an inverse, then this map, so suppose G, you generally denote this as F or F inverse. So this is basically, it's a map from 0 to and this map is basically log map. Okay, this map is basically log map. Okay, X goes to log X. Since this map is an inverse of this map, this exponential map, that's why the domain of this map is J is 0 to infinity. Is it clear? Okay. So the thing is, okay, so now you know, so basically you know this one. Okay, you always know that domain of this function is 0 to infinity. Okay.
Yes.
But the main problem is if suppose something else is given, like instead of log x, something else is given, let's say log of some
log 2 minus x.
Suppose log of some h of x is given.
Okay.
H of x is given. Okay. So the thing is, you know that log x, you can find out log of x if and only if this x is positive. Right. So similarly, you can find out log of h of x if and
Wow.
only if
hx is greater than 0.
h of x is greater than 0. So the main thing is to find out the domain of this one, to find the domain of this function. Domain, what you need to do, you need to find the values of x. Okay, you need to find values of x for which
H is greater than 0.
h of x is greater than 0. So you need to find that range for which this h of x is greater than 0. Okay, and precisely that is what we did in this previous question, right? We basically
It's like a composite function.
Correct. So basically what we have done here, we tried to find the values of x for which this. So here log of h of x. So here h of x is what? H of x is this function. Okay, this one. Okay, so we tried to find the values of x for which this expression x time e to the power 3x minus 27x is greater than 0. Okay, probably question number three is also similar to this. Okay, so let me write this question. So what you need to do?
Question number 2 also, sir, just show one.
No, same question number. Okay. Question number 2 is slightly easy, right?
That's the math. It will be easier to get the
So what is the question number? So, okay, so 6.1 question number 2. So you have a function, right? So this is your function. So this is log of 2, right?
Yes.
2
log of 2 minus x.
Okay, so this is your function, and what is your aim? You need to find the
2 minus x greater than 0, right?
Correct. So you need to find the domain of this function. So the same argument, right? So whatever
it will be similar like yes, sir, our question.
Yes, whatever I have explained here. So here you have, so instead of x, so instead of this one, you have this one, right? So now what you need to do, you need to find the values of x for which this h of x is greater than 0. Okay, so here h of x is what? H of x is 2 minus x.
2 minus x.
So you need to find the values of x for which h of x is greater than 0. That means 2 is greater than x. So if you take all the values which are less than 2, that are basically in the domain of f. That means x is basically
minus infinity.
Minus infinity.
Minus infinity. Okay.
Minus infinity.
So this is now the main question. So what is the domain of f? So the domain of f is basically minus infinity to 2, because these are the value for which h of x is greater than 0.
Yes, now I get it.
Okay.
I'm getting it.
Okay, so let me solve the next question. So you have another question, activity 6.1, question number 3, right? So the question is the same. So now the function is different, but you need to find the same thing. You need to find the domain of the function. Okay, so the function is, my next function is
pretty big function.
This is big, but okay, so finding the domain is not difficult.
Same concept as above.
Because you need to use the same concept. Okay, so
yes,
but the concept is same, but you need to use
have
it
to simplify this function first.
Yeah, you need to use it. The different trick. Minus 8 log. Sorry, 15. Okay.
Plus 15, sir.
So,
sir, firstly solve the outer log, or solve for outer log.
Yeah, okay. So now you have something. So now what you have, so as I have already explained, so you have something like this log of h of x, right? So you need to find this first. You have to find this h of x. What is h of x here?
It's
What is it?
log x base 10 whole square.
So this is whatever this function is, this is in the form of log base 10 h of x. So if you compare, so what is h of x? So h of
We will
x
take
is,
first only the one expression.
no, what is there inside the whole.
Total. Okay.
Yes, because see, this is in the form of log of h of x. So then h of x is basically the whole expression, right?
Yes.
Not a single term. Okay. So when you are taking, so when we have computed this log 2 of 2 minus x, so you are not calculating when 2 is greater than 0.
So we can take substitute log x10 as
Just a
a
minute,
y
just
or
a minute,
z.
just a minute. Okay, so in the previous question, what we did, we have calculated the region for which the whole function is greater than zero. We are not calculating individually, right? See, this is also you here also you have two functions. One is 2, another one is minus x, right? But we have calculated
together 2 minus x greater than
correct,
0.
for the whole function. Okay, so similarly we'll do the same thing here. We'll calculate for the whole function. So here h of x is what? H of x is log 10x square minus so we want
15, sir.
okay, sorry.
Plus
So
15.
we want all the values of x for which this h of x is greater than 0. It's not greater than 0, greater than equal to 0. It's strictly greater than 0. Okay. So
we have to solve this like a quadratic equation.
Correct. So
Like
still
the
now
middle
it's
term.
still now it's clear.
Yes, sir.
Why can't we just take out log 10
Yeah, you can.
from
Sorry,
log 10?
which
We
one?
have to substitute, I think, log 10x
Oh,
with
no.
something.
Just a minute. Let him. Sorry. What is your question?
Sir, my question is why can't we just take out log base 10x common from log 10 means log x base 10 square minus 8 log x base 10.
Last term में नहीं है ना common.
So you are saying.
Plus 15 is only.
So you can do that, right? This you can write. If you want to write this, you can write log x.
Then we are having log base 10x again, and then minus 8.
You want to write like this, right?
Yes, sir.
Yeah. So fine. So then. Yeah. Now.
Oh.
Yeah. So now next what? So you want to find the values of x for which this one, the second one, which is similar to the previous one, which is same as the previous one, is greater than 0. So then what is your next step?
It will not work.
Sir, it will not work, but we can.
You can do that, but probably it will be slightly difficult. Okay, so then I don't know, but I have to maybe work. So then you will get from here, you will get log 10 x. I don't think it will work.
Okay. So it will be easier if we do that 15 minus 3 log x minus
that is fine. That is the natural way to solve this.
Natural way to solve.
Okay, then now it's slightly trickier. Okay, so now you don't know how you should proceed. Okay, because
Okay, I understand.
So it's better. So this is now, as you can see, it's more or less in a quadratic form, right?
Yes, sir.
So basically you have some square, then you have the linear term, and you have some constant. Okay, so now what you do, you try to solve it as a quadratic. So instead of log, okay, I don't want to write the same thing over again and again. So instead of log 10x, I'll simply replace this as m, right? So okay, sir. So this is my So m, so from now on m will, so m basically represent this thing. Okay, so then this h of x is basically what? It's basically
M square.
m. Okay, remember that
square.
m is a function of x. Okay, so a is basically m square
Minus 8m
plus
plus 15.
We want this to be greater than
And
0,
greater
right?
than 0, yes, sir.
So now you know how to factorize this polynomial, right?
It's 5.
Yes, sir.
3 and
This
5.
is basically you
5
have
and
two
3.
yeah, so you have two roots. The sum of the
Minus
roots is basically 8 and the product of root is 15. So then you have m minus
5 and
5
3.
5 5.
M minus
Minus
5 and
3.
minus 3.
3. Okay, so this, so you want this to be greater than 0, right?
Yes, sir.
Yes.
So
Yes, sir.
when this is greater than 0, when this thing
5.
M greater
3 to
than 5
When m
to
greater
5.
than 5 and m greater
and
than
M greater than 3.
correct. So when, so the when m is greater than 5 or
M greater than 3.
Greater
m is
than
less
3.
than 3.
Less than 3, sir.
Okay. So same thing, right? See, the way we have, I gave some argument, right? So here we have calculated that when
अरे
m
हाँ,
times.
क्लास चल रही है मैं करती हूँ बाद में हाँ
Okay, please mute yourself.
Sorry.
Yeah, fine.
Sorry.
So now, so similarly the same thing. When product of two things is less than, if one of them is negative and another one is positive. So if you use the similar kind of argument, so you will get this. M
So
is,
here m will be greater than 3, right? Not less than.
Yes.
no,
This
M,
thing, I'm so confused this step.
Yes, sir. Here, what? How we can take m is
M5,
smaller
M
than
minus
3?
greater than 0 or M minus greater than 0.
okay,
no?
okay,
Yeah,
okay.
both would be greater, right?
It will
Okay, so-
represent in number line. You will get.
So the okay, let me tell you the answer. Okay,
Yeah,
so
please,
let me tell you the one case is one is m is greater than 5 or
M is less than 3.
m is
Uh,
less than 3. Okay.
How
So
you
how I'm
please
getting
explain this thing?
yeah.
Yeah.
So again, like again the same logic. Okay, you have two number a b, right? The a times b is positive. So when it is possible, when product of
When
two
both are
both-
positive or both are negative?
Yes, correct.
both positive,
Both positive
both
or
negative.
both negative.
negative. Okay. Both negative. So now we have instead of a and b, we have m minus 5 and m minus
3.
3. And I want this to be greater than 0, right?
Right.
So the first thing is when both are positive, that means m is greater than 5 and m is greater than 3.
Yes.
Okay.
Right. So
Yeah.
this, so from here what I'm getting, the range is
M is greater than 5.
5 to infinity.
Yeah.
Okay.
Yes.
So here I'm getting the range is
3 to infinity. Why not 5 to infinity? Okay.
we have to,
Yeah.
so
Got it,
certainly we have to take the common region, right? Because
region.
Right.
because
Right.
I want both of them to be positive, right?
Right.
So if I take this region, okay, this is true, but this is
Yeah.
not true, right?
Yes.
But I want both of them to be true, correct?
Yes.
I want both of them to be positive.
Okay.
So if I take, so instead of this, if I take this one, then certainly this is positive. M is greater than 3, but certainly M is not, but this condition is not true. So I have to take the common region. If I take the common region, what I will get? I will get
M greater than 5. Okay.
5 to
m
infinity.
greater than 5.
You get a 5 to
Huh.
infinity. Yes, get
Okay.
it.
Yes.
So this is what you are getting when you are considering that both the
Both are
term are
positive.
Both are positive. Yeah.
yes.
Yeah.
So the next thing is, okay, let's take both are negative. That is m is
Right.
greater than m minus 5 is less than 0 and m minus 3 is less than 0, right? That means m is less than 5
Yes.
and
And
m
M is less than 3.
3. Then now what is your common region? So one is minus
5
infinity
minus 5 minus into
5 and another one is minus infinity to 3.
Infinity to 3.
So what is the common region? What is the common region? So you have a line, right?
Minus
Can you
infinity to
explain
3.
it on a number lines?
You have a line. Right? This is
Minus
your,
infinity to 3
okay.
is a
Okay.
common.
Yeah. So let me explain. Like I guess most of you know the answer, but yeah, let me explain. Okay. So this is your number line, right? So one region is this one, minus infinity to 5.
Minus 5.
Minus infinity to 5, right? So this is your common. This is your region which represent minus infinity to 5.
Yes.
And you have another region which is
minus infinity to
so you have another region which is 3, right?
Right.
And you have, this is basically minus infinity to 3. So now what is your common region?
minus infinity.
Minus infinity to
Infinity
3.
to 3.
Certainly
Ah.
this part is not common, right?
Yes, sir.
No.
So this part is common.
Yes.
So yeah, so basically, yeah, if you basically what we are doing, common means what? We are taking the intersection, right? We are taking minus 5 intersection minus
infinity to 3.
3. Okay.
Oh.
And
Okay.
it's clear that, see, if you see, this is basically, if you see this 4 is here. Okay. So 4 is here, right? But
Yes.
4 is not
But
here.
4 is not there. Yes.
But that means certainly this cannot be the intersection, right?
No.
Yes.
So then basically this is your intersection, minus infinity to 3.
Ah.
So
Yes.
okay, so finally what we have, okay, so if you go and see what we were doing, okay, so now okay, let me recall what we were doing. So we want this function to be greater than 0, right? So this my main function f of x is basically in the form of log base 10 with some h of x, right? So I want this h of x to be greater than 0, right? So
Yes.
so my h of x is basically log base 10x square minus 8 times log 10x plus 15. Okay, so and as you can see, this is basically, it's a quadratic thing. So
Yes.
what I did, I replaced this log with something which
Constant.
it's not constant. Actually, it's better. I can write this as
Substitute value.
m of x,
Substitution. Yeah.
m of x, but I'm not writing it. I'm simply writing it as m. Okay, so
Okay.
so so I'm replacing this by m. This, so then I have this quadratic function. So this is basically m square minus 810 plus 15, which is greater than 0, because I want h of x to be greater than 0.
Sir, a small query here at this point. M equal to 10x base 10. So when we resubstitute it in place of m, shall we take this anti-log or directly we will?
I'll come to that. I'll come to that when I'll solve. So finally, when I have to solve, then basically I have to go back from here to here. Okay, then only I can get the answer. So now I have this quadratic formula and I have substituted. Once I factorize this, I have this. I can write it as m minus 5 into m minus 3, and this m minus 5 into m minus 3 is greater than 0 if either m is greater than 5 or m is less than 3, right? So that means this thing is greater than 0 if m is in between 5 to infinity union
minus infinity to 3.
3, right?
Okay.
That means so now I can so what is my m? M is basically log x base 10, right? So this is, so then
yes.
So basically then h of x is, so finally I can write h of x is positive if and only if m, which is nothing but log x base 10, is in this interval. Right? So so now from this I need to find the range of x, right? So when log 10x is basically greater than equal to, so log x base 10 is in this interval. That means this is basically same thing as log 10x is greater than 5, right? Correct?
Greater than 5. Okay.
If and only if x is greater than
10 to the power 5.
10 to the power 5. If and only
By definition, we have to
correct.
do this.
If and only if x is basically in between 10 to the power 5
3.
infinite. And I have one more thing. So I'm done with this interval, and I have one more thing. So by the same
Less than
argument,
log
I can say that log
less than 3.
is basically in between minus infinity to 3 if and only if log
X less
is less than 3,
than
right?
3.
Which is same as
X equal to 10 to the power 3.
x is less than
Less than 10 to the power 3.
which is same as x is
Okay, that's why 10 to the power 5, 3 came. Okay.
which is same as minus infinity to 10 to the power 3. Is it clear how actually we are
Yes.
getting the range? Sorry, not range, the domain of this function.
Domain. Yes.
Okay, so now, yeah.
So can you put this up so that I can take the screenshot?
Okay, so you can take the screenshot. Mostly I'll share the PDF. Okay, so.
Okay. Then that will be very easier for us to.
Okay, so.
Thank you.
Yeah, so I guess now you can find the domain of function which is of this form, right? Some h of x, right? Now, so the main idea, whatever question we solve, the main idea is basically to find the values of x, to find the values of x for which my h of x is greater than 0, right? This is what we have done for the last 3 questions, whatever we solved. So basically we have tried to find the values of x for which the h of x is greater than 0.
Excuse me, sir.
Sir, sorry to interrupt.
Sir, can you explain the concept of mod breaking?
Sir, can you explain the bijective thing you explained earlier?
Which one?
The bijective property.
Okay, someone asked me mod breaking. What is that?
Yes.
What is mod breaking?
Sir, it will given the functions in mod, and
we break them.
Can you
asking for particular range in particular range domain?
No, your question is not at all clear to me. Like what is your question? Like I don't know what is mod breaking.
Say example of x minus 3, mod x minus 3. So how it will react, means how it will, what will be the range of that function?
Sorry, x minus
3 mod.
Mod of x minus 3.
Yeah. No. Now, if you break it, you will
no.
get
Sorry,
x
Spera, please. No, it's not clear to me. What is your function? X minus 3.
Mod x minus 3.
This is your
Is there
function.
a whole x minus 3 inside mode?
Yeah. So,
Now, what will be the range of this function?
Yes, sir.
So what is your guess?
Sir, it will depends on the restricted domain.
Yeah.
Restricted
domain. So what is your domain?
It's not equal to 3.
Okay, so let him tell what actually. So what is so this is your function. So what is your domain? What is your domain for this function? In which domain you want to define this function? Sorry.
Okay, so if I have to define a function, then means let's say it is defined for R to R, or reals to all reals.
Sir, domain can be minus infinity to plus infinity, but range can be 0 to plus infinity.
Domain, it's up to you. Like I can I can restrict this function to some subset of R. Maybe I can define from natural number to R. So it's up to me. So he wants to define it from R to R. Okay, so this is modulus, right? So this is always greater than equal to 0.
Okay.
Then
So if it is always equal to greater than equal to 0, then what are the values for that? This x is means this function is defined. Any value that is
this function is defined for all real. That's why you can define, you can make a function. So whenever you are saying that you want to define this function from R to R, so I guess you are assuming that this function is not assuming, basically this function is valid for all real. Okay, so you can define this function for all real. Otherwise I cannot write this as from R to R. So when I'm writing this is from R to R. So basically or in some sense I'm proving, or maybe not proving, I'm assuming that this function is defined for all reals. Okay, so if this function is not defined for all reals, then I cannot write that this is a function from R to R. Okay, so when I'm saying that f is a function from R to R, that means this function is defined. This function is defined for all reals. Okay, otherwise I can't write. Yeah. So one thing is clear, that this is basically this x minus 3 is a modulus function. This is always greater than 0.
So there will be two values, right? We will neglect one values, but there will be two values.
Sorry, why there will be two values?
Either x should be greater than 3 or 3 should be less than x.
But sir, if we open the mod for some function, it will be open as positive and negative also.
Yeah, just a minute. I'll discuss all these things later. Probably, yeah. So so basically this requires a lot of things. Like basically, what I guess you are confused with the definition of function. So okay, let me tell you the answer. This is always positive. Okay, x minus 3 is modulus is always positive. So the function whatever you have defined, so this range is a range of that function is nothing but 0
to infinity.
To infinity.
Yes.
But sir, sometimes the functions inside the mod, it will open as like x minus 3 is greater or equal to 0, or x minus 3 is
for different function you will get different things. Okay, so for this function I'm just saying, so if you define something,
sir, can you explain?
I'll come to that. Okay, so let me explain the things that are in week 6.
Then week 6.
Question number 4, sir.
No, someone asked me something bijectivity of something. Okay. So what I forgot the question.
Sir, the bijective, yeah, this slide only. This is bijective you written. So, yeah, this is a bijection. You written this. So can you explain this once more, please?
No, like you have, so main thing is, okay, I am not, so basically I have stated it. I have not proved it. Okay, so because I didn't show how to prove that this is a bijection. I'm just saying that this is a bijection. Okay,
so from the graph we know that this is a one-to-one function. But for onto function, the range should be equal to codomain, right?
Yeah, so you can see, right? So this is basically it's a asymptote, right?
Yeah.
So it's a asymptote, and this keeps increasing. Okay, so basically you can see all the positive values of y are basically in the range of this function, right?
Yeah.
So that's why this the range of this function.
And what will be the codomain of this function then, sir?
See, the thing is, again, like the codomain is depend on how I write the function. Okay, so the way I have written here. Okay, so the way I have written here, see, if I have written something like this, f is from R to this. Okay, that means this is my domain.
Yeah.
This is my codomain.
Yeah.
Right.
And if we write,
then sir, how it onto function?
It turns out that here the range basically coincide with the codomain. Okay, so in this case, it turns out that the codomain is nothing but the range. Okay, so that's why it's a onto function. As I said, probably you need, so the argument I guess Sar gave is using the graph of the function. Okay, but to prove it precisely, I guess you need continuity. Okay, you certainly you cannot do it.
For onto function, every pre-image are equal to the image. Both are equal, right?
Can you say it again?
Range and
in for onto function, image, the number, the image and pre-image both will be equal, right?
What is pre-image?
The range.
No, range and pre-image.
Pre-image, no, sorry, domain. Pre-image means domain. Image means
Pre-image means also not domain. Okay, pre-image you basically you talk pre-image of a single element in your codomain. Okay, so it's pre-image is something different. Don't mix the things. Okay, domain is something different. Pre-image is something different. Pre-image is subset of a domain, but pre-image may not be domain. Okay, range is different. Codomain.
I didn't know that thing. I think pre-image is domain and
no.
Domain is image.
Pre-image is a relative thing. Okay, pre-image means, okay, if I'm defining, let's say I'm defining a map, let's say from R to R, and my x goes to x square. Okay, so now what is the pre-image of
all real numbers?
Pre-image of 3, pre-image of 9. What is the pre-image of 9?
What is the pre-image of 9?
9 is basically 3 and minus 3.
Yes.
Okay. The pre-image of R is basically R. Okay. So if you take the pre-image of whole codomain, then you will get the domain. Okay, but if you take the pre-image of only 9, then you are getting something different. It says certainly 3 minus 3 is a subset of your domain, but it's not equal to the domain. Okay. So pre-image is sort of relative. It's a local thing. Okay, you can talk about pre-image of an element in the codomain. Okay, so domain is something something different. Range is different. Codomain is different. Okay, so so in this case, I defined this map from R to this 0, infinity, and it turns out that this map is injective and as well as surjective. Okay, that means surjective means what? Here the domain, here the codomain and the range they are same. Okay, so that means this is a bijective map. Since this is a bijective map, then only I can talk about its inverse, and that inverse is precisely your logarithmic map. Okay. Is it clear?
Sir, we are neglecting one also, right? So
neglecting
one.
Oh,
it should not be equal to 1.
Which one?
A should not be equal to 1, right?
Yeah, A should not. There are so many conditions. It's not like A should not be. A is.
Should we also show it in 0 to infinity and / 1 or something like that?
No, now you are mixing
because
with,
it is including 1 also na in that range.
Okay. Let me. So when you are saying that, okay. So when you are saying problem is now you are mixing so many things.
Yes, sir. Everything is so messed up.
So now you cannot take A to be negative. Okay, you cannot take A to be 1. Okay. But if I take A to be 2, if my A is 2, then I will get a map from. So this is a map from R to 0 infinity, R to 0 comma infinity open interval. So if I take 0, what I will get? 2 to the power 0, which is 1, right? So
Okay.
1 is in the range of F, right?
Okay.
So when you are saying, see, A cannot be 1. Okay, so this A has nothing to do with this domain and codomain. Okay, see, here I cannot write 1 power x. Okay, this is not possible. If I'm writing 1 power x, then this is not true. This function is not surjective, because I will always get 1. So that's why we're excluding 1. So we're excluding 1. So A cannot take 1. Okay. And similarly, A cannot take negative number, because you will get some complex thing. Okay. So this A can be 2, A can be 3, A can be 4, A can be let's say 0.5. Okay. So this A has nothing to do with this thing.
Range.
It is for an exponential function.
Yes.
The range is
previous
defined for the exponent of A, right? Okay, I got it now.
No, range is defined for the value that this function can take. Okay, so what are the value this function can take?
Yeah,
what are the value this for if you take A equal to 2, what are the value this 2 power x can take? That is the range. What are the value this 2 power x not can, will take? Okay, that is precisely the range of the function. Okay, and okay, so one more thing I'll suggest. Okay, so each and every week you try to revisit the thing that you studied in week 1. Okay, so the main thing is week 1 is the most important thing in maths 1 and as well as in maths 2. Okay, so if you know week 1 properly, then basically you don't have to worry about all these things. You can easily, so you know what is the domain, what is the range, and once you know all these things, then these are pretty obvious. Okay, so then you have a clear idea. So the most thing, so now what I see, like most of you are confused with the concept of week 1. So if you are confused with the concept of week 1, then certainly then these are even so whatever I'm doing, this will be more confusing. Okay, because if you don't know how to compute the range of x square, or maybe mod of x, or some domain of this function, then certainly it will be too difficult for you to compute the domain of this function. Okay, so I'll suggest in each and every week you spend some time in week 1. Okay, it's you spend some 1 hour, maybe 1.5 hour in week 1. Okay, you try to revisit the things. Okay, it will be useful for you throughout the course. Okay, even if you go to linear algebra, or maybe whatever subject you do, this function relation, they are basically the base of that subject. Like if you go to the machine learning also, you need all these things. Without function you cannot do anything. Okay, if you know, so once you have a function, then certainly you will have a domain and codomain and range, all these things. Okay, so try to spend some time in each and every week for week 1. Okay.
Sir, please share the document after this class.
Yes. So
and sir, another thing also, last night there is another math class, but its YouTube video is not available.
Okay, I'll ask them.
Not for the last yesterday's class only, like for last 2 or 3
on demand.
There was a solve with.
It will not uploaded on YouTube. Told by sir.
The solve with TA, we are not going to upload it it in YouTube, because
Sir,
it
on demand session will not upload it on YouTube.
probably.
Okay.
Then probably will not also like upload this on demand session. Okay, on demand session, like who are interested, they can come and ask the question. It's basically for the people who are basically interested and they have some extra doubt.
Okay.
Okay, so yeah, so
Sir,
okay, so
question number 4 on that 6.1.
okay, so basically I have solved all the questions from 6.1.
So this is the concept is new to us, so
Yeah, that
we
is
are
fine. That is fine.
confusing.
That is fine. But again, like so the thing again, I'll request all of you to try to spend some time.
Yes, sir.
On week 1.
Yes, sir.
Because like I have seen, like many people, this when they go to maths to this, like they struggle on completely unnecessary thing in maths too, because of this. They don't know properly what is how to find the domain and range of the function of a function. Okay, so I have this function. So this is my function, and basically the same thing. I need to find the domain of this function, right? The question is slightly different. You need to find all the points for which the function is not defined, right? So
Yeah, the base is complicated also now. So this the expression is scary kind of.
Okay, so you need to find, so once I know for which the value of the function is defined, then basically I know the values of x for which this function is not defined, right? Hello?
Yes, sir.
Yes.
Yeah, so is it clear? Like once I know for which values of x this function is defined, then basically I know for which value of x this function is not defined.
Yes.
I'll just have to take the complement, right?
Yes.
Okay, so this is x square plus 1, right?
Sir, we have solved for base also in this question.
Sorry?
Sir, we have to solve x for base also in this question.
Yes, correct. Yeah. So we need to find we need to find the values for which this is greater than 0, right?
Yes.
We now we have two variables. We have to take care of this and as well as this, right? So let me first take care of this one. Okay. So the first thing I want this to be positive, right? I want x square is positive. So when this is positive, I've already explained to you how you should find. So any idea how
x square plus 1 then greater than x square minus 1. This kind of.
No, I have explained
0,
you.
no.
Yeah. So
Can't we make the base and the variable
okay.
same?
X square minus
okay.
1 always greater than.
I give you 2 minutes, or maybe 2-3 minutes. You try to give me the answer, like how we can compute the region for which this function is greater than 0. You try to think and tell me. Okay. You take time, maybe 2-3 minutes, 5 minutes also you take, but I need an answer because I have explained you similar kind of thing just before.
Sir, minus infinity to minus 1 or 1 to infinity?
Sorry?
Minus infinity to minus 1 and 1 to infinity.
Yeah.
Yes.
So okay, so this is probably correct, but I want the explanation.
X equal. Then x equal greater than 1 and
No,
x less.
No, sorry. I want an explanation, like why in this region this function is greater than 0.
Because sir, if value is between -1 and 1, this function become negative. This value become negative, x square plus 1 upon x square minus 1.
Then
So
we have to
that-
find x plus 1 into x minus 1 greater than 0.
Sorry.
We just divided the x square minus 1 into x plus 1 and x minus 1.
The denominator become negative when we
सर
do
1 to infinity
minus
इस
one.
रीजन में दोनों ही पॉजिटिव है, नॉमिनेटर एंड डिनोमिनेटर. माइनस इन्फिनिटी टू -1 रीजन में दोनों ही नेगेटिव है, नॉमिनेटर डिनोमिनेटर. सो इन बोथ ऑफ दिस केस इट बिकम ग्रेटर देन 0.
Correct. So
Sir,
okay.
Sir,
so
if we take the 1, denominator will be 0, no, sir?
Sorry, just a minute. Just a minute. Yeah, so that's why I am excluding -1 and 1, right? So I am taking the open interval. So when you are saying, okay, so basically you are saying this is, so when you are saying in this region this is positive, and as well as in this region this is positive. Okay, so then basically you are saying, yeah, in this region this function is positive, but you are not proving that this is the only region in which the function is positive.
Sir, it will in the numerator x square plus 1 is always positive. So we take care of only denominator. That's why it will come.
Yeah, correct. So basically, yeah. So this, whatever the answer, someone
Yes,
said
sir.
this is correct, but okay. So the thing is, I have already explained you, like if you the probably the simplest method, like if you see.
Sir, x square plus 1 is always positive.
So this is what? This is basically x square minus 1. Okay.
Yes.
Right. And you have two things, one and another one, right? And when this is positive, so you have A and B. When both of them are positive and when both of them are negative. So the thing is, this A cannot be negative, right?
Yes, it will always positive.
X square plus 1 is always greater than,
always positive.
Always
positive,
greater than 0.
Okay,
greater than 0.
So you don't have that second case. So the first case is when both of them are always positive. So this x square plus 1 is positive for all x, right?
Yes.
And I have to find the region in which x square minus this 1 by x square minus 1 is greater than 0, which is same thing as x square minus 1 is greater than 0, right?
Yes.
And you know this is greater than 0 if x is basically in between -1 to 1. Sorry, -1
-1 and 1 to infinity.
Okay, so
yes,
basically
that thing I got it.
Yeah, so basically this function, so whatever is there over here, this is positive. So now this one is positive if and only if the value of x is in between -1 to 1 union sorry
1 to
infinity.
minus infinity to -1
and 1 to infinity. Yes.
Okay, so at the same time I have some another function over here in the base, right? So here, so in the base I have this one, right? Not x minus 1.
X minus 1 by x plus 1.
It will greater than 1.
So why this is greater than 1?
Sir, because base of log is defined only for greater than 1.
No, this is defined for, okay, this is basically defined for all the a for which are greater than 0 and not equal to 1. Okay. So as you can see, this a, so this a, so do you agree x minus 1 is always less than x plus 1?
Yes, sir. By
Yes.
graph.
You agree, right?
Yes, sir.
So that means always
Less
greater
than
than
1.
always, sorry, less than 1. But at the same time, I want this to be greater than 0, right?
Yes.
Yes.
So when this is greater than 0, when x minus 1 by x plus 1 is greater than 0.
Sir,
When
phi.
Market is
Sir, can you please repeat the last?
Phi कुछ नहीं आएगा.
0.
So this is my A, right?
Yes.
So there is a condition on A. A has to be greater than 0.
Not equal to.
And A cannot be equal to 1, right?
Yes, sir.
So the next thing is what I'm saying. It's basically, so as you can see, x minus 1, A is nothing but x minus 1 by x plus 1, right?
Yes.
So do you agree that x minus 1 is always less than x plus 1?
Yes.
Yes, sir.
Yes.
So that means x minus 1 divided by x plus 1 is always less than 1.
Right.
So I don't have to worry about this condition, right? Because my A cannot be 1, right?
Yes.
Yes, it's less than 1.
So I'm fine with this condition, right? So
Yes.
now this condition is okay, but I have to make sure that this A has to be greater than 0, right?
Yes.
So I have to make sure that this x minus 1 by x plus 1 is greater than 0, right? So when this thing is greater than 0, x minus
when
1 by
x is greater than 0, greater than 1, sorry.
Yeah, when x is greater than
1.
When x is greater than 1, sure.
Yes, sir.
Why?
Because
What if you take x to be, let's say, minus 5?
sir, minus 5 is less than 1. I am saying greater than 1.
And x less than minus 1 also. Less than minus.
Then it will be less than 0.
X less than minus.
You use the same argument, whatever argument. Again, like if you are having difficulty to solve this, then start with the simple method. Okay, don't jump into some complicated thing. Start with the simple method. You have A, you have B, then you try to solve this. Okay, so that is the simplest method to deal with all these things. Once you are comfortable with this kind of thing, then you can jump to some kind of different method. But first you should try to do it the simplest method. Okay. So again, you try to write this x minus 1 or maybe 1 by x. You try to find when this is greater than 0 and this is, you take two different cases. So if you take, then basically you'll get this one.
It's greater than 1 or it's less than minus 1.
So basically x is minus infinity to minus 1 union
1 to infinity.
And in the first case, if you go to the first case, this is precisely what we get in the first case, right?
Yes.
So that means what is the domain of this function?
Minus 1, 1 to infinity.
So the domain of f is right. This is the domain.
Yes.
And basically we are left with what? Minus 1 to
minus 1 to 1.
So that means for all these values, the function is not defined. Okay.
Okay. Yeah. Getting it.
Okay. Okay. So this is clear, like how actually we are solving this question, how we are getting the domain of this function. Okay. Fine.
Pretty clear. We have to just practice with it more and more so that.
Yes. Okay.
Sir, is the all properties of log is valid for natural log also, like log of mn is equal to log m plus log n?
It's not for natural log. It's valid for all the bases. Okay.
Okay.
So if like it's valid for all the bases, like obviously you have to exclude these two things, right? A cannot be 1 and A has to be greater than 0. You, apart from like if you take anything in this range, then all the properties of log are
Okay.
okay. Any other doubt?
Sir, in Desmos, how do we give that log base?
Log base.
I cannot draw I cannot see the log graph in the Desmos. Like log base 2 something.
You
So
have to
how
use
could
underscore.
Yeah, I guess
Underscore.
you have to use the
Underscore, sir.
Yeah,
underscore?
Yeah, then only you will get.
That's, I'm not able to get it. That's why I'm just asking.
Yeah, you use that thing, that underscore. So okay,
Yes, it's working.
it's working, right?
Yes.
Okay, fine.
Thank you.
Yeah, thanks.
Sir, activity 6.2, question number 2.
Okay, activity 6.2, question number 2. Okay, so my next question. So yeah, so have you tried any
Yes,
question,
sir.
or because you basically you have asked all the question from activity, okay, apart from question number 1. So okay, so let me take 6.2, question number 2. So have you, so in which option you are facing problem?
Sir, let me just. The inverse of log of mod x is e to the power mod x. Why it's wrong? I'm not getting this.
Okay, let me discuss it because I guess many of you have not started solving question number 2, activity 6. So so this question has 4 options. So the first option is basically f is a increasing function.
I'm also going to ask this question.
Sir, make graph of ln of mod x and then interpret.
Okay, so I'll do that. Okay, let me first f is an increasing function and the straight line x equal to 0 is an asymptote. Then the inverse of f is what? E to power e power mod x.
Mod x.
And the last
The
option.
first two are true, na sir?
Okay, I'll come to that. Okay, just first.
I didn't get the third one. Yeah,
I'll come to that. Okay, let me first complete.
Okay.
Domain of this is, and the domain of minus infinity to 0 union 0 to infinity. Okay, so what about question number option 1?
1 is true, sir. I think. True.
1 is true.
Sir, yes, log x is always increasing.
Okay. Log of
No,
x.
sir, no, sir. It will mod x.
It has
ln of
to
mod
be
x.
a greater than 1, then it will be
It will be a
increasing.
mod x, not ln x.
So this is a different function, right? So
yes.
So what is the so what is the domain of this function?
All real numbers.
Positive.
All real numbers.
Not all real numbers. You have to
Positive numbers.
Zero. Yes.
Positive
All
again. So no, like who is saying again? You are not using the thing that I have just now. I told you. What is h here?
Mod x greater
What is
than
h?
Mod x.
H.
Mod x.
What is it? Mod x. What is h of x? Is mod x. When mod of x is greater than 0.
For all real numbers.
not for all real number. You have to exclude 0, right?
Exclude zero.
Yes,
Yeah.
yes.
So
Real number
Positive
minus
real
zero.
number. Positive real number.
Exclude minus zero. Exclude zero.
0 to infinity.
so for all these values of x, your mod of
Mod
x
is greater than zero.
0, right? So
Yes.
that means f of x is greater than sorry, that means this is the domain of f of x, right?
Yes.
Right?
Yes.
So now, do you think this function is an increasing function?
Yes, sir.
Decrease in somewhere.
So from minus infinity to 0, it will decrease and then it will increase.
It will be break.
But it will not define the restricted domain. Then why we can say that it will increase in or decrease?
Sorry?
It will not mention the restricted domain. We have C2 in restricted domain. It will increasing or decreasing. Then how we can say directly?
No, this is the domain, right? We have this domain, right? What is the domain of this function? This is the domain, right? This is the domain of this function. So in this domain, you can check, right, whether this function is decreasing or increasing.
Increasing,
Yes,
sir.
sir. When we move from minus infinity to 0,
once you know the domain, then certainly you can check whether this function is decreasing or increasing, or it's neither decreasing or increasing. Okay. So the thing is, as you see, it's pretty easy to tell that this function is not increasing, because
it will be not increasing.
Yeah. So if you take minus 10, which is less than 2, right?
Yes, sir.
Minus 10 is less than 2, right?
Yes,
but
sir.
Log of, what is f of minus 10?
So log 10.
This is log 10, right?
And log 10 is 1.
Which is greater than log 2.
Yes,
right?
sir.
So as you can see, x is less than y, but but f of x is
Greater than
f of
y.
So that means this function cannot be increasing. Okay. So let's try to draw the graph. What will be the graph of this function? So see in the right hand side, we'll have something like this, right?
Sir, it will be a reflection of of the graph Lnx about x-axis.
Correct. Not x-axis.
It's y equal to x.
Not y equal to x. Okay.
y-axis.
X-axis, I think. If we
Just a minute.
the y-axis.
Let me complete. Okay. So basically, you will get something like this. You will basically get the reflection with respect to this y-axis. Because see, whatever value you are getting at x, the same value you are getting at minus x, right? So basically you will get the mirror thing with respect to this y-axis. So this is basically the graph of this function, right?
Sir.
So that means it's not increasing or decreasing, as well as not increasing, not decreasing.
Yes, it's neither increasing nor decreasing. Yeah.
Okay. Thank you.
So
yeah.
Sir, what is the graph of mod of Lnx here?
Mod of
Lnx.
Mod of Lnx.
Yes, sir.
All the negative values.
But okay, so no, just a minute. What is the domain of mod of Lnx?
Sir, minus infinity to 0 and 0 to infinity.
Why? What is the value of this function at -1? What is the value of this function at -1?
Sir, ln of -1, but it will not define.
Yeah. So then how it the domain is basically from -infinity to.
Sir, then domain is 0 to infinity.
No, that
All positive.
Yeah,
numbers
basically
excluding zero.
again the same thing. Like, see what you want. Basically you are not. The problem is you are not using the thing that I have told you maybe 10-15 times. So what you want? You want this to be greater than 0, right? So it doesn't matter whether you have a modulus outside of the function. The only thing you need to get the inside. So here you have only x. So that means you want this x to be greater than 0. That means the domain of the function is basically 0 to infinity, right? So so that is the domain. So now, but what you are doing now, instead of taking lnx, you are taking the modulus. Okay, so now what you will do, this is the graph of lnx, right? This is the graph of
So yes, sir, take reflection about x-axis.
Just a minute. Okay, so again, like, just let me say something that I want to say. Okay, the most of the time you people are not allow me to complete what I want to say. Okay, so this is the graph of this function. So as you can see in this part, in this part, if you take only this part, in this part, lnx is positive. Okay, so if I take the modulus, then basically I'll get the same thing, right? If I take the modulus of something, then I'll get the same thing. But here, but in this part, in the below part, I have negative thing. So if I take the modulus, then I'll land something here, not here. If I take the modulus of this part, if I take the modulus of this part, I'll land somewhere here. If I'll take the modulus this part, I'll land somewhere here. So what basically I'll get something like this. Okay, I'll get something like this. So this is the graph of modulus of
lnx.
Because now so basically whatever this negative part, that will become positive because I'm taking a modulus. So this is the graph of lnx modulus, okay, or modulus of lnx. Okay. Is it clear like how actually we're getting this graph?
Yes, sir.
Yes, sir.
Okay, fine. So yeah, so this part is clear now. This f is not a increasing function, right? So this is not possible.
Yes, sir.
Now the next option is x equal to 0 is an asymptote, right?
Yes.
Which is more or less clear. More or less clear if you draw the graph, right?
Yes, sir.
Because x equal to 0 means what? X equal to 0 means what? Which axis?
Y, asymptote to y axis.
Y axis. So basically it's saying, when it's saying that this line x equal to 0 is an asymptote, it's basically saying y axis is an asymptote. So it's clear that this y axis is an asymptote. Okay.
Yes,
so the second option is true, right? What about the third option? Hello.
Yeah, inverse of fx is e to the power mod x. How to find the
okay, so the first thing is whether this function is 1
e to the power is 1 to 1.
No. I'm talking about I'm talking about this function. So before talking about the invert.
No, sir. It will not 1.
No, sir. It is not 1.
Because at -1 and 1, it will give me the same value, right?
Same value.
Yes.
So that means this my function, whatever function I have written here, this is not one function. That means this function I cannot talk about
Inverse.
Inverse.
Yeah, inverse
got
of this
it.
function. Okay, so then this function don't have inverse. Okay,
Inverse.
so this is certainly incorrect.
Sir, excuse me, sir. Just one query. Just you spoke about this the function being 1, 1. So because it is not 1, 1, so we are checking that
Not
condition
1,
of
1.
invertible, right?
Sorry, just let me repeat. It's not 1, 1 in this domain.
In this domain, yes, yes.
So this is the domain. Actually, we are calculating first the domain. So this is the domain, and in this domain, this function is not 1. Yeah.
Yes.
Now.
So
Continue.
Functions being invertible, we are concluding this, right? We are checking this 1, 1 and onto things, right?
Yes, yes.
Okay,
yes.
okay, yes, sir.
Yes,
Thank
yes.
you, sir. Yeah.
Yeah.
Sir, how the graph look like of e to the power mod x?
E to the power mod x. It's the same thing, right? So as you can see here, like you will have, okay, so okay, what happened? Just a minute. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir. Okay, so so if you draw the graph of e power x, what is the graph of e power x? What is the graph of e power x?
It's just asymptote to y
Yes.
x-axis and is going up.
Yes, sir.
Yes.
Like
so this
that.
is the graph of e power x, right?
Yes.
So if you, instead of e power x, if you take e power mod x, okay. So so if you try to draw the graph, so the main problem is when you are taking modulus e to the mod x, the main problem is the left hand side, right? This side, because here instead of the natural thing, you are getting something different. Okay, instead of -2, you are getting 2, right? So so the main problem is you will face in the left hand side. Okay, so in this side, as you can see, the graph will be same, right? Because so e power 2 for this function, value of f of 2, if I take f of x is equal to e power x, and if I take another function g of x equal to e power mod x, okay, so at positive real, the value of f of x and g of x, they are same, right? So then I'll get the same thing in this
in this positive domain. Yes.
Now the main problem is
negative.
In negative domain, I'll get precisely the same thing, right? For e power mod x, because at 2,
then it will also increase.
At 2, what is the value of e power mod x? It's e2, right? Also
e to the power 2.
-2, also I am getting the same thing,
e to the
right?
power 2.
E power 2. So
it's like a curve again going up. Okay.
Like a
Quadratic.
It's not quadratic actually. Quadratic is slightly
like a parabola axis.
No, it's not parabola. Like it's because the rate in which e of x increases is actually much more than parabola. So,
yeah. But shape like that, but
yes, but yeah, some kind of, you can say locally, because we are actually seeing some small picture, right? If you see the big picture, then the growth is too much.
Yes.
In -4 e to the power e to the power 4, so it's so high.
So this is basically whatever you are getting here, this part is basically the reflection with respect to y-axis. So this part is basically reflection with respect to
y-axis. Right. Yes.
Okay.
Got it.
Okay. So and already we have calculated the domain of this function. Okay.
Yes.
So that's why this option 2 and 4 are correct. Okay, is it clear now how actually
Yes, sir.
we are concluding that option 2 and 4 are correct?
Yes, sir. Clear.
Okay. Okay, so any other question? Because I guess we have time. So
I didn't go through further. I just did that up to that much only.
Okay. Okay, any other question or like one?
Can you pick the topic of Sir Mod, which you talked about? Please?
No, mod means what? Like what you want me to talk about modulus?
Sir, I want to basically know how the mods break in intervals or like that.
Mod break in the interval, like no, the thing is, okay, so you have two things, right? See, modulus, the first thing is you have to know how the modulus is defined.
Yes.
So what is the definition of mod of x?
Sir, for x positive, it will open positively, and for x negative, it will open negative.
No, like so first you have to remember the definition. See, mod of x is basically x if x is greater than 0, right?
Yes, sir.
It is minus a.
Yes, sir.
If x is
negative,
less than 0. Okay, so this is how we define modulus. Okay, now it's depend like how. So see, we are saying that okay, this is modulus, but okay, so modulus can come with something else. So instead of x, it can come with something like this, some modulus of some different function h of x. Okay, just now we saw that we are taking modulus of log x. So it's depend on the function, like one. So unless you are not you don't have the function, then certainly it's difficult for me to tell you how it breaks in all these things. So this is the only thing I can tell. Okay, this is how the modulus is defined, but how it breaks, it's completely like I can hardly what I can do. I can draw the graph of the modulus function. Okay, so this is, if you see, so so in this positive part, this is basically this is x, and the negative part it's minus x. Minus of negative is basically positive. So I'll get the mirror like basically the mirror image with respect to this y-axis. Okay. So yeah, so that is what I can like tell about modulus function.
Okay.
But if you want like some, I still I don't know how it breaks. Means it's certainly it's depend on the function. So if you have some function in your mind, then probably we can discuss.
No, sir, I don't remember.
Sorry, in this parenthesis x or minus x, in both scenario we will get mod x equal to x and minus x. In this scenario we get the same output. If we put -1 to get 1, -2 to actually what question क्या कहना चाह रहा मैं एक्चुअल में ये समझना चाह रहा यहाँ से.
No, so no, the thing is what you are asking. You are asking about this definition or something else?
This definition about it, what
so
does mean it?
So this means, so basically this is, as you can see, I have defined this function something else for this region, right?
Okay.
In this region, my value of function is x. right?
Yeah.
But in this region, my value of function is something different. It's minus x. For example, if I take x equal to 2,
yeah.
So what is mod of x?
2.
Because 2 falls in this region, right?
Right.
2 falls in this region, and according to this, I have defined that the value of the function is x, and here x is 2. That's why modulus of 2 is
2.
2, right? And if I take x equal to minus 2, what is modulus of minus 2?
2.
Yeah, because see now what I'm doing, I'm checking the region. Now minus 2 falls in this region.
Negative side. Yeah.
So since minus 2 falls in this region, then what I have to take? I have to take minus of x. And here what is x? X is minus 2.
Minus
right?
2.
Then, but what I have to take? I have to take minus of x. That is minus of minus 2, right?
Right.
Which is 2. Correct? So this is what actually I defined. Okay, so modulus of x is x. When x is greater than 0, it's minus x. When x is in between minus infinity to 0.
But in a graph, actually this like a y equal to mod x, like this type thing, or is a some different thing?
This graph.
Yeah. For minus 2 and 2, graph cuts something at y.2. For plus 2, it cut 2. That actually y equal to f of x equal to mod of x. Then you define the mod of x in this x is greater than 0 or x is greater than.
Correct.
Okay, so okay.
Yeah. So basically at minus 2, you have the value of the function is 2, right? So that means this point is basically 2 minus 2, 2. And at this, similarly, this 2, the value of the function is 2, which is this point is 2, 2. Yeah.
Okay, sir.
Sir, I have a question about what I'm asking to how to solve this type of question. Sir, can I ask?
Yeah. So what is your question?
Sir, 2 to the power mod x minus mod of 2 to the power x minus 1.
2 to the power mod x minus
mod of
2
to the power x minus 1.
X minus 1.
Minus 1, sir. Minus 1. सर x -1 भी रहेगा ऊपर में पावर में. Yes sir, equal to 2 to the power x -1 plus 1.
Equal to 2 to the power
x -1 plus 1.
X minus 1 plus 1, right?
Yes sir.
Okay. So the main thing here is, so now, so as you can see, the main problematic part here is you have two modules, right?
Yes sir, yes sir.
Right, you have two modules, correct? So if you want to solve the equation, first thing is you have to get rid of this modulus sign. Okay, so until then you cannot do anything. Okay, so one thing you know, this mod of x, right?
Yes sir.
This mod of x is, by definition, it's x if x is what? If
Positive.
x is greater than 0.
Greater or equal to 0, yes.
And it is negative.
X is less than 0.
If x is
तो यहाँ पे equal भी होगा ना positive में.
हाँ, मत. You can take it as greater than equal to. Yeah. So now you have this thing. Now so this I know how I can separate this 2 to the power mod x. So I can write this, the first term, as 2 to the power x if x is greater than 0, greater than equal to 0, and it's
Yes,
2 to the power minus x if x is
less than 0.
less than 0. So now I can know how I can get rid of this modulus sign for this one, right?
Yes, sir.
The next thing what I should do, I should try to get rid of this mod sign for this one, right? The second term of this expression. So the next thing is what? Okay, so now the next thing is 2 to the power x minus 1.
Minus 1.
We are taking the modulus.
Yes, sir.
Okay. So the first thing is I have to find out for what values of x this 2 power x minus 1 minus 1 is greater than 0. See, if this is greater than 0, 2 power x minus 1 is greater than 0, then modulus of this is basically nothing but this, right?
Yes, sir.
If this is less than 0, this 2 power x minus 1 is less than 0, then modulus will come something like this, right?
Yes. Yes.
So the next thing what I need to do, I need to find the region for which this function, whatever is there, it's positive, right?
Yes, sir.
So when this is positive, when this is greater than 1, right?
Yes, sir.
That means x minus 1 is greater than what? What?
0.
0, 0.
0.
Log 1 हो जाएगा 0. Yes.
Yes. That means x is
greater than 1.
Greater than equal to 1. So for this region, this function is positive, right?
Yes, sir.
So, and if x is less than 1, this function is negative, right?
Yes, sir.
So now I know how to write this function. So this x minus 1 minus 1 modulus is 2x minus 1 minus 1 if x is greater than equal to 1. It's minus 2x minus of 2x minus 1 minus 1 if x is less than, right? So now I know everything. Now since I know the region for which this past two terms where these first two terms are positive or negatives, since I have calculated, so then I can remove this modulus sign, right? So but now you have to take care of the region. Okay, so for example, if I take this region, for example, if I take 0, 1 in this region, this is positive, right? But this is negative, right?
Yes, sir.
In 1, infinity, this is positive as well as this is positive.
Yes,
right?
sir. Both are positive.
And the next thing is what? You have minus infinity to 0. This is negative as well as this is negative. Okay. So now you have to take 3 cases and you have to solve accordingly. Okay. Is it clear?
Yes, sir. Clear.
Okay. Okay. So next thing is probably you have to do bunch of calculation, like you have to.
Yes, sir. Yes, sir. Basically, this is what I'm asking.
Okay.
How
Fine.
to break model.
Yes. Fine. Okay.
Okay. Thank you.
Okay. Thanks. Okay, then I'll stop the session.
A small doubt in the
yes, please. Yeah.
Please open it, sir.
Sorry.
Please open the graded assignment of week 6, sir.
Okay, graded assignment.
I'm not able to see your screen.
Okay, you want me to share the screen?
Yes, sir, because I'm watching in YouTube, sir.
Okay, just a minute. Fine, right? Now you can see.
Yes, sir. Last question. Gold question, sir. Gold question. Above, sir. Above. This question, 8 questions, sir. Please give me some hints, sir, to how to solve this question.
So the function is given, right? Some f of m, something is given, right?
Yes, sir. I simplified that f of m, sir. It will be log m plus 1 base 10 plus log 10 base m plus 1.
No, so the thing is, okay, so for example, if you want to, so okay, in one of the so let's say pick the option number 3. It's basically saying that the jeweler sold at least 2 kg gold daily throughout the year in 2019, right? That means throughout all the day of 2009,
yes, sir,
he sold at least 2 kg, right? And it's given that the amount of gold sold by the jeweler on the mth day of 2009 is given by something, right? So basically it's saying that for each value of m, okay, for each value of m, the value of the function is always greater than equal to 2, right?
Always greater than equal to, sir?
Equal to 2.
Yes, sir. Yes, sir. Okay.
So if you try to interpret this option 3 mathematically, it's basically saying for each value of 2, for each value of m, the value of the function is always greater than equal to 2, right?
Yes, sir.
So basically you need to check whether this value of the function is always greater than equal to 2 or not.
Okay, sir.
So yeah, so you try to do it. So once you solve this one, then it's more or less easy for you to solve the other one.
Okay, sir. I will try, sir. Thank you, sir.
Yeah, so the thing is you have to modify this function little bit to check whether this option is true or not. Okay, so you certainly cannot do it directly from this, because you have some 0.01, then probably you have to modify it. Okay.
So at least 2 kg per day. 365 into 2, right, sir?
Sorry?
At least 2 kg per day. So total will be 2 into 365.
Yes.
So this will be less than it should be less than the actual one, right, sir? Okay, so I will try. Thank you, sir.
Yeah. Okay, so then I'll stop the session. Okay, thank you all.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yes.